So we're going to do these just like we graphed absolute value equations. The only difference is if it does not have an equal to under the inequality, then our v, our graph of the absolute value function, will be a dashed line. Okay, if it does not have an equal to, like number 1 and 3 do not, then the v will be a dashed line. Okay, if it does have the equal to, like 2 and 4, it's a regular solid line like it always is. And we're going to shade. Okay, there's shading involved in this, and I'll explain why after we do one. If it's greater than, you shade above. That makes sense, right? Greater than above, less than below. All right, makes sense. So let's graph these just like we were graphing yesterday. We need to start by finding the vertex. So we take what's inside the absolute value, set it equal to 0. So we get -1 for the x value of our vertex. When we plug that back in, -1 plus 1 is 0. So the y value is 0. -1, 0 is our vertex. So we count down, we count up, we fill in our table. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. It is symmetric, so I get the same values over there. Now, my pen's kind of fat, so it's hard to do this, but it does not have the equal to, so this should be a dashed line. So if you kind of want to like skip every other square, that's one way to do it. Bless you. Okay, this one is less than, so we are going to shade below our graph here. You don't need to spend 10 minutes fully coloring everything in. Just make sure that it's clear that this is what is shaded below it. Okay, I know that's not very pretty. It drives my perfectionist side of me crazy, but sometimes you just gotta let it go, right? All right, so what this means is it means any point in that shaded region will make this inequality hold true. So let me just pick 0, -4, okay? So if my y value is -4 and my x value is 0, is that inequality true? -4 is less than the absolute value of 1. Yes, that is true. I could have picked any point. I could have picked, let's say, 6, 2 over here. If our y value is 2 and our x value is 6, then that inequality holds true. 2 is less than the absolute value of 7. Okay, any point in that shaded region will make that inequality true. That's what this whole graphing and shading stuff is all about. Okay, let's do another one. Number 2. Let's find the vertex. X minus 5, set it equal to 0. So our vertex is at +5. So count down, 4, 3, 2. Count up, 6, 7, 8. The y value of our vertex, when we plug in 5, 5 minus 5 is 0. 0 minus 2 is -2. So 5, -2 is our vertex. When we plug in 6, we get 1 minus 2, -1. Plug in 7, 2 minus 2 is 0. Plug in 8, 3 minus 2 is 1. We've got symmetry, so I can fill in the other side. -1, 0, 1. Okay, this one does have the equal to, so we can just fill this in like we normally do with a solid line. Okay, this one is greater than, so we shade above this graph, which means we're shading in between, so to speak, the function there. Now, let me show you. Your calculator will actually kind of do this sort of stuff for you. If we type this into our y equals math over num, ABS, x minus 5. Just don't forget to close the parentheses after the 5 before you put the minus 2. Have you ever wondered what those slashes are over there on the left side? Okay, I'm getting ready to show you. If you move your cursor all the way over there so that it's blinking, if you press enter, all of a sudden it becomes a thicker line. When you press enter again, there's a triangle up here on the top. That represents greater than. If I press enter again, the triangle looks like it's on the bottom. That represents less than. If you keep going, I can't remember what that part does. That'll do a dashed line right there. But if you keep pressing enter, it just scrolls through them all. So if you miss it, you just keep pressing enter. You'll come back to it. So this is greater than. So I want the triangle that's on the top. When I press graph, look at that. It matches my picture. Okay? It matches my picture. So if you need something to check yourself, your calculator will show you. All right, let's look at number 3. Absolute value of 4x plus 6. Find the vertex. 4x plus 6 is equal to 0. 4x equals negative 6. Divide by 4. That gives us negative 3 over 2. Or negative 1.5. When we plug that in, we get 0. So I'm going to use negative 2, negative 3, negative 4, negative 1, 0, and 1. Now, this one did not fall on a whole number, but it's right in between two whole numbers. So we can use symmetry here because it's exactly the same distance from negative 2 as it is from negative 1. The one we did yesterday was like 2/3. It wasn't the same distance to the whole number on each side. So when we plug in negative 1, we get what? 2? When we plug in 0, no, yes. When we plug in 0, we get 6. When we plug in 1, we get 10. When we plug in negative 2, we get 2. Negative 3 gives us 6. Negative 4 gives us 10. So obviously our graphs don't go to 10. So negative 1.50 is our vertex. Negative 2, positive 2, negative 1, positive 2, 0, 6, and negative 3, 6. This one does not have the equal to. It's kind of hard to make this one dashed, but just do your best. Just make sure it's not a solid line. This one is greater than, so we're shading above, so that means we shade in between. That's about as good as mine's going to get without it just looking like a big, huge blob and the dashes blending with the shading. So, okay, let's do one more to review another thing about these absolute values, and then I'll let y'all practice for a second. F of x is less than or equal to negative absolute value of 2x plus 3. So where's our vertex? 0. What's the y value? 3. When we plug in 0, we get the negative absolute value of 0, which is 0. 0 plus 3 is 3. All right, so negative 1, negative 2, negative 3, 1, 2, and 3. So when we plug in 1, 2 times 1 is 2. Absolute value is still 2. But there's a negative in front of it. So it's negative 2 plus 3, which is 1. Plug in 2, we get negative 4 plus 3, which is negative 1. Plug in 3, we get negative 6 plus 3, which is negative 3. It is symmetric, so I'm going to use those values over here. 0, 3, 1, 1, 2, negative 1, 3, negative 3. Okay, this one is less than or equal to, so we can use our solid line. It is less than, so we are shading below. So it's still in between, but that's because this one's opening downward because of that negative in front of the absolute value. That's what I wanted to point out. When there's a negative in front of the absolute value, it flips it over. Okay? All right.